Hi, I'm Fran, and this is the diffraction apparatus. The diffraction apparatus consists of three parts. First, there's a red laser, 635 nanometers plus or minus 5 nanometers. Second, there's a set of precision slits, metal film on glass. Third, a combination high-sensitivity light sensor and linear position sensor. The high-sensitivity light sensor has a selectable aperture, so you can control how much light gets into it. It also has 3 settings for 1, 10, or 100 microwatts of power. The linear position sensor has an internal optical encoder and has a resolution of about 40 micrometers, and that lets you do this experiment without having to use a micrometer screw. I'm going to show you 2 different slit patterns that you can collect data with this apparatus. First, I need to adjust my laser to make sure that it's going to be actually pointing through the slit. And there are 2 screws at the back that let me turn it and get it centered. And if I put this in the center, I can use that to help me guide getting the diffraction pattern to the right location. Now I'm going to select a double slit pattern, and I'm going to choose one where the separation is 0.25 millimeters and the slits have a width of 0.04 millimeters. To begin data collection, I'm going to move the linear position sensor all the way over to the right of the carriage. That means that when I push it to the left, I'm going to get positive position values. I'm going to zero my sensors. And then once I start collecting data, I'll have about 30 seconds to move the carriage all the way across over 15 centimeters. Now, it doesn't matter what rate I go at. I am not looking at the intensity versus time. I'm looking at it versus position. And that means that I can even pause while collecting data, and it's not going to affect how that comes out. It also does not matter if I finish data collection a little bit early. So here's my data, and let's look at that auto-scaled graph. You can clearly see maxima and minima and the extra fringes from that 2-slit diffraction pattern. The other one I'd like to show you is a multiple slit pattern with 5 slits that are also 0.04 millimeters wide, but which are separated by a distance of 0.125 millimeters. And there they are. Once again, move the carriage all the way to the right. 0 sensors. And you'll see that this diffraction pattern is different because of the multiple slits. So you can use the examine function to look at the locations of the maxima and minima for the diffraction pattern and use that for mathematical calculations regarding the wavelength of the laser or the slit separation of the slits. There are many experiments that you can do with this. As always, more information is available at our website, www.vernier.com. Thank you.